All right, guys. Thank you. Looking at the first part of 5.2, it says, find the y-intercept of the graph of each function. These are not quadratics. These are linears. You've learned thus far how to find y-intercepts of linears. How do you know what that is? Because do you recognize its form? What form is it? Slope-intercept, y equals mx plus b. So the 3 is the y-intercept, right? You know that because you have become more familiar with that form. -1 is the y-intercept, right? What form is this? Standard. We're not as, we have to rearrange it, right? It's an ugly stepsister, yes. If you were to subtract the 4x and then divide the -3, 12 divided by -3, the y-intercept over here would be -4. So you learn, you have become familiar with this stuff. As familiar as you are with this stuff, turn the page, we now are going to want to become familiar with some of the properties of quadratic functions. So first thing we're doing is today's lesson, we look at graphs of quadratic functions that are in standard form. So here are two graphs of quadratic functions. At this point, you should know enough to tell me what is the name of this graph. It is a parabola or parabola. There are some very specific things that you need to just become familiar. As you're learning these and you're going to do it on ACT and you're going to have your calculator to look at the graphs, it's nice if you just know, just at a glance, some of what you can expect. So let's talk about those. First off, come up here, circle this first bullet point. When a is greater than 0, the parabola opens up. When a is less than 0, the parabola opens down. This is just like the absolute value V graph. Positive a's, the V graph opened up, right? Right, guys? Negative a's, the V graph would be flipped or reflected and opened down, right? Same thing on the parabolas. Here, we have an a greater than 0 or positive. It opens up. Here, this would be an a less than 0, so we should actually have like a negative sign right there, a negative a, so it would open down. So once you add that negative right there, it's actually a negative a. So opening up, opening down. We know that by just looking at the a. The next thing we know, the axis of symmetry. Circle that bullet point. We're working through them. Put a star by this. Have you heard of that somewhere? Negative b over 2a. The b and the a are up here. That's the coefficient. Say it with me. Say coefficient. Not the x, but the coefficient of the x. So a is always the coefficient of the quadratic term. B is always the coefficient of the what term? What is that term? Linear term. Very good. If I know that, it tells me if this graph is shifted right or if this graph is shifted left. It'll give me the axis of symmetry. So right here, there's an axis of symmetry that has been scooted over to the right. Here's an axis of symmetry that's been scooted over to the left. And then that parabola will be symmetric around it. So if I'm looking at standard form, I can use that to see if I've shifted right or left. That's the x shift. Also, negative b over 2a will be the x coordinate of the vertex. So it tells you where to move. The x coordinate. So look down here. Here's a vertex. The x is negative b over 2a. So wherever negative b over 2a took you, so let's just imagine that was 1, 2. That said, hey, x needs to be 2. What would I do with 2 to get, what is that telling me to do? What do I do with that value to get the, what do I do with that 2, though? I know my x is 2. How do I know, what am I going to do with that 2 to find the y, to find the output? Where would I put 2 in order to know the output? This is This is where you got to think for a minute here. You got to put together what we're talking about. Negative b over 2a gives me this x.
Oh, it would be the,
It's talking about it right here, the y value of the function, if x is negative b over 2a, and y would be the f of negative b over 2a. What does that mean? What does that mean? How am I going to know the y coordinate of the vertex? All this notation right here, I'm going to simplify for you, but listen, I wanted you to be able to say this. You should be able to say this, but you're just not realizing what you're looking at. All you got to do is, if that negative b over 2a gave me a value of 2, I plug it in to the function. I plug 2 in. So like right here, I would put a 2 in for that x and a 2 in for that x and see what output it produces.
that's what I'm saying.
Is that what you're trying to say?
I was trying to say that. That's what
Okay.
I'm saying. Why you put it
But y would equal, yeah, whatever y equals at that x value. You with me on that? So your vertex can be found a negative b over 2a for the x. That's the axis of symmetry. That's your x coordinate. What do we do with that x? We plug it in, and it'll get your y. So there you go. That is the anatomy. That's the properties of parabolas. We are going to graph this one right here. I want to show you where to go. So take that quadratic formula, y equals x squared minus 2x minus 3. Turn in your notebook to your first graph. You have some graph pages back in your notebook. Y equals. Somebody tell me again, what was that y equals?
was y equals x squared minus 2x minus 3.
So there I have a quadratic. You will be required to do the graph on your homework and on your test. Let me say it again. You'll be required to take this quadratic function or equation and put the graph on a coordinate plane with a pencil. You can do that two ways. You can understand these properties we're talking about, or you can also look at it on your calculator and make sure you understand the properties you're looking at, put it on there, but I will require you to make the graph. That's how you start learning more and more about parabolas. So let's do this. First thing I want to know, I can see, I think I missed one. Hang on. I just remember this. Oh, yes. Before we go any farther, I want to hit this. Back over here, the last thing, circle this bullet point. The y-intercept is 0c. What is the c we're talking about? The constant, yes. It's part of the standard form. If you look at the standard form equations, if I was to put 0 in for x, 0 here, that would go away. 0 here, that would go away, leaving y would equal whatever c value is. Y'all follow that thought? Come down here on this bottom one. If I was to put 0 right here, that would be nothing, right? Minus 0, that'd be nothing. So in this one right here, when x is 0, the y is c, or negative 3. So that gives me an easy point. Knowing that property, you knew how to find the y-intercept of a straight line when it was in slope-intercept form. Now, when it's in standard form, you'll know, hey, the y-intercept is that last value, that constant, because that's what this thing will equal if I zero everything else out. So that's good. Hey, when you get 1 point on a parabola, how many points does it give you? What'd you say? 1. Every point on a parabola has one that corresponds to it, a cross. We'll look at that here in a second. All right, hey, there it is. Negative 3. So hey, everybody just go over there. I don't even know anything else, but I know that parabola will cross at negative 3. I usually don't put it on there first. First thing I want to know is where's its axis of symmetry? How am I going to know its axis of symmetry? Someone tell me. Look at you. Some of you forgot it already. Negative b over 2a. Let's put that into practice. Negative b over 2a. With your pencil, put it into practice. This is how this sticks. What is b? Negative 2, so this becomes a positive 2, right? Follow me? Do it with your pencil. This is how you learn these properties. What is a? An invisible 1. So 2 times 1 is 2 over 2, which makes 1. Come to this coordinate plane and put a dashed line at x equals 1. That's a vertical line of x equals 1. That is our axis of symmetry. So that point right there, I know there's one that corresponds to it directly across. Y'all agree? Is this parabola opening up? So that means the vertex must be below here somewhere, huh? See how I can understand properties? I couldn't have a vertex up here because then it would be opening down. So, all right, so let's talk about our vertex. What's the x-coordinate of my vertex? 1. It has to be on my axis, doesn't it? Can y'all put 1 into this? What's 1 squared? Minus 1 minus 2 would be what? Negative 1 minus 3? Negative 4. We were predicting it to be lower, weren't we? So 1 over, down 1, 2, 3, 4. There it is. So this parabola, I don't know much more than its vertex is down here, and there was its y-intercept. So another point corresponds. So that's the bottom of that parabola, opening up. On your lesson, it's going to ask you to identify minimum or maximum. Does that parabola have a minimum or does that parabola have a maximum? Minimum. It's got these arrows go up forever, so it's going to continue on extending up and out forever. So it will never reach a high point. It goes on, but when it comes down and turns, that will be its lowest point. So that is the minimum at the vertex. I sometimes just say the minimum of y equaling negative 4. The minimum is the value, the lowest y value. On your ACT, if you were to take an ACT and it asks you that question, it might ask for what's the lowest y value as a minimum. You just have to look at your answers. Or it might be asking for that point, 1 negative 4 as the minimum. So look closely at how it asks that question for the minimum. Okay, that is the ins and outs of how to take a quadratic equation and put it on a graph. It's real simple, just new.